All right, in this video, we're going to go over how to solve Cournot's model of duopoly. This is a model from the 19th century. It's one of the most important models in modern economics. Probably up to this point in introductory classes, intermediate classes, you talk about perfectly competitive firms. These are firms that the market's so big that there's just a price and they can't change the price. They're a price taker. They have no impact on the price. Or a monopolist. A monopolist doesn't have any competition, so we often call these price makers. They get to set a price. Well, so it's actually really hard to think of any real-world example that fits either of these models. In most cases, there's a small number of firms, and how much a firm should charge or how much they should produce, well, it depends. It depends on what the other firms are doing. These are games. So duopoly, we just mean where there's two firms, and it doesn't seem like it'd be such a big deal to go from one firm to two firms, but it's a huge deal. This is why we didn't make any progress on this until game theory came around, because it requires an entirely new way of thinking about how the firms are going to act. Okay. So this is a really simple model of two firms, but it's already complicated enough that interesting stuff is going to happen. We have two different firms, and so this was a model by Cournot in France in the 19th century, and so you're supposed to be thinking about farms. You've got two farms, and they're trying to figure out what quantity to grow of a crop. Okay, so each firm chooses a quantity, and then at the end of the season, they're going to take it to market, and there's going to be a market price that's set. And so the market price, the more they grow, the less the price is going to be. So it's just normal supply and demand where the demand slopes downwards. But the problem for these firms is that it depends on how much both of them produce. So if the other guy produces a whole lot, not only is that going to drive down the price for him, it's going to drive down the price for you as well. Okay. So all of this to say is that the price they're going to get is some parameter A minus the quantity of firm 1 minus the quantity of firm 2. Okay. So the more they produce, the less the price is going to be. And don't let the A throw you off. The A is just supposed to make this a general model. You can, if you want to, plug in a number like 100 or 200 into there. It doesn't change anything. A is not the important part. Each firm has a fixed constant marginal cost of C. And again, if you want to, just put 20 here instead of C. But it's just supposed to make it a little bit more general. Okay, so I encourage you to pause and try to solve this. This actually is a challenge. What makes this a challenge is we're not going to do anything hard. We're going to have a sequence of questions. Each question is not a particularly challenging question, but it's really hard to know what questions to ask and in what order to ask them. Okay? So I want you to keep in mind our overall approach here is what's a strategy, what's a firm's best response to a strategy, and then what's a mutual best response. That's how we're going to go about solving this. Firm 2's strategy is a quantity. Our goal is to figure out firm 1's best response to this quantity. This one's a little trickier than others because we actually have to figure out what firm 1's objective is. It's a firm, so what firm 1 is trying to maximize is profits. So again, we're trying to calculate the best response. So we're trying to figure out what choice by firm 1 maximizes profits. So this is the Q1 that maximizes firm 1's profits. Like any objective function, we take the derivative and set it equal to 0. Now, on a test, you might get a little confused at this point. We see 4 letters here, and you know you need to solve for one of the letters. Which of the letters do we solve for? Just remember what we're trying to do. We're trying to figure out the quantity of firm 1 that maximizes their profits. So we're solving for Q1. Now we just need to do a little bit of algebra. This is the Q1 that maximizes profits. This is our best response. So we've just solved this. We've just figured out the best response of firm 1 to firm 2. So this problem is completely symmetric. Firm 2 faces the same decision firm 1 does. We don't need to do this twice. We know that firm 2's best response is going to be exactly the same as firm 1. So remember our steps. The first step was to find what's a strategy. Second step is to figure out what is the best response to a strategy. And the final step is we know in equilibrium, both people have to be doing a best response. So now we're looking for a mutual best response. And there's nothing special about these stars. This is just a little trick I use to remind myself that we're talking about in an equilibrium. Okay, we have two equations. We have two unknowns. The way you solve this is to just stick the one equation into the other. This is a symmetric game, so Q2 is going to be the same as Q1, but probably a better way of solving it is to stick Q1 into the best response function for firm 2. And that's it. We found our Nash equilibrium. Firm 1 and firm 2 both choose A minus C over 3.